Hello, welcome to Taxonomy Online Mathematics. In this episode, we want to take tutorial on the topic relations and function. And in this particular edition, we are going to deal with the definition of a relation. If time permits, we'll move to definition of function. We'll talk about some key terms as in the domain, codomain, range, and ordered pairs. We'll proceed with the types of the various relations that we have. So if we are talking of the definition of a relation, we are only referring to a rule that unites two quantities where one quantity depends on the other quantity. So one quantity is dependent and the other one is independent. So in this case, if I have a relation such as y equals to 4x minus 1, this equation relates two quantities which are x and y, where the value of y depends on the value of x. So in this case, y is a dependent variable where x is independent variable, because the value of x does not depend on y, but that of y depend on x to be able to find its value. That is a relation. So we are to relate two quantities whereby the quantity of one relate with what? Another quantity. What we are trying to outline is that this is the dependent variable. This is the independent variable. So these are two quantities that are being related. Now, under relation, we also make use of two sets. That is the two quantities, either quantities or set. So if I want to refer to two sets, the first set is what we refer to as what? The domain. So if I have a set of values, let's say this is a set of values that is 1, 2, 3. If I have another set of values, this is another set of values. Now, if I want to relate, I want to unite, I want to connect these two sets. The first set is what we are calling what? The domain, which in this case is the independent what? Variable. Then the second set is called the codomain, or better still, we can call it what? The range. So if I map this, we can see that each of the elements in the first set, which in this case our domain, is having a corresponding element in the codomain. Now, the element here is called an object, where if I want to relate one with one, this one is called the image. The image of 1. The image of 2 is 4. The image of 3 is 9. Now, all these sets, 1, 4, 9, is what we call what? The codomain. Or better still, the range. Now, the range is a subset. It's a subset of the codomain. Meaning, if I extend this, set of elements, I can say that each of the elements here is having something here. But you can see the 25 is not having an object mapped from the first set. So if I want to mention the codomain, the second set from which we are doing our relation for, it will be 1, 4, 9, and 25. The codomain, the dependent variable. Then if I want to mention the range are values or the element in the second set that has mapping from the first set. So our range is going to be 1, 4, 9. The set of range is going to be 1, 4, 9. Then the domain is going to be 1, 4, 9, 25. So in this case, if you said a domain, we are referring to the elements of the first set, or better still, the independent variable, the set of independent variable. Then if you are talking of codomain, that become the set of dependent variable. This element depend on this, because this is going to be is a square of. Is a square of, meaning this is a square of this. We are saying dependent. Which one is dependent? Is a square of this. This particular one, which is what? The set of this can also be labeled as what? Y. Y, this is what? X, and this is what? Y. As we can see here, X is the independent, Y is the dependent. X is the independent, Y is the dependent. So it's a square of, meaning this depends on this to produce. A square of this is 1. A square of this is this. A square of this give us this. You get the concept? So in this definition, a codomain is just the set of values of the second set, or the dependent set. The range I explained is a subset. A range is a subset of elements from the codomain, where the ordered pair is going to mean that a unit set like this, 1 and 1, is an ordered set. So ordered pair, not a set. Then this is going to be 2 and 1, 4. It's another ordered pair. Then 3 and 1, 9. Is also another ordered pair. So referring to the ordered pair, this is what we can produce from that. Then we have types of set that are relation, or type of relation. So we have 1-to-1 relation. Don't forget you're referring to two quantity or two set, right? So if 1-to-1, it means one element in the first set has a relation with what? One element in the second set. So from this, we can give this as an example of 1-to-1 relation. If you go to the school setting, if you are in a classroom that contain library, let's say reading books, a student to a book, that is 1-to-1 relation. If you are 12 in a class and a book you are to read is also 12, that means 1-to-1. Okay. Then we have 1-to-many. 1-to-many. This simply means that one element in the first set has a relation of what? More than one element in the second set. So let's say we have a set. So the element in the first set, which is the domain X, map to this. We can see 25 map to 5 and -5. -5 and 5 are not the same. We can also describe this as what? Is a. So it means that these values are produced as a result of square root of this. We know if we square 25, we know we have plus or minus what? 5. The square root of 25. We can get plus or minus without the absolute value. We can get plus or minus what? 5. So this is the minus and the plus. The same thing if you square 4, you will get what? Plus or minus 2 without the absolute value. So you are going to get 2 and minus. So one element is having two elements in the codomain. One element mapped to more than one. So it's 1-to-many. This element also has two elements there. So this is 1-to-many relation, whereby we can have what? One person dealing with what? Two items. In that case, we have 1-to-many relation. All right. Then the third one is going to be many-to-one. Many-to-one, which is the opposite, direct opposite of this. Two or more elements in the codomain has only one element in the domain. Many of them has only one. That will be an example of what? Many-to-one. So let's see how best we can also relate this. Label it. So the description of this relation is a product of. So this is a product of 2. 6 is also a product of what? 3. Is 6 a product of this? No. But we can say that 20 is a product of 4. The same time is a product of what? 5. So we are saying many, meaning more than one element. So these two elements in the first set map to only one element in the second set, whereby these two elements also map to only this. So we can see that two elements here are mapping to only one. That could be in the sense of a class whereby there are 30 students, but they have only 15 books to read, which means 2 students to a book. 2 students to a book, which means 2 as in many to one book. That is a relation for many to one. Then the last one, which is many to many, could be a combination of all that we have stated so far. So let's call this is less than. So we can say that the values of x is less than that of the values of what? Y. So this case, this is less than this. The same time, okay, so this is going to be 4 is less than 10 and 15, whilst 5 is less than 10, 15, 3 is less than 10, 15, and 3. So in this relation, how really do we see the many to many? 1. Let's try and see if we can get 1 to many, meaning one element in the domain has 2. Then if 1 in the domain, a codomain also have what? 2 in the domain, then we have what? Many to 1, 1 to many, all combined together to give a what? Many to many. So this is 1 to many. 4 is having 2 elements, so I can see 1 to many there. 5 is having 2 elements, 1 to many. 2 is also having what? 1, 2, 3, so it's 1 to many. But let me see 15. 15 is having what? 4 and what? 5, meaning many to 1. Many to 1. If I take 10, which is also having 1, having 4, 5, and 2. So many to 1, 1 to many. So we can classify this as what? Many to many relation. Alright, so these are the various type of relations that we have. Now, if you want to marry this with a function, function is also a special kind of what? Relation. Whereby in this case, an element in the domain has only one element in the codomain. An element in the domain has only one element in the codomain. There should not be duplicate element in the codomain. So in this case, 1 to 1, if I have A, B, C, if this goes this way, this is a function because A has only one element. This has only one element. So I can call this 1 to 1 function. It's a relation, it's a function. So this is an example of what? A type of function. Then 1 to many. The definition says that one element in the domain has only one element in the codomain. So if 1 to many, that is, if an element A is also mapping, let's say, this. If A is mapping to Y and Z, this is 1 to 2, that is 1 to many. And this 1 to many is having A having one duplicate element. So this is not a function. A should have only one element in the codomain. Only one element. So this is not. Then let's take many to 1. Element in the domain has one element in the codomain. So many to 1. How many elements is 2 having in the codomain? 1, that is 6. How many elements is 3 having? It has only 1. How many elements is 4 having? Only 20. 5 is only 20. But this is many to 1. Since an element in the domain is having only one element in the codomain, this is also a function. So we can also call this a function. Where this is going to give us, this is having 1, 2. So obviously, this is not going to be a relation. So among the 4 types of relations, 2 is a function. 2 of them is a function, and normally we represent a function as in this form, or we can also use f of x, as we can see in this way, where our f of x is our dependent what variable, depending on the value of what x. All right, so in the next episode we will take function into detail, where we will define the how to prove a function is what one-to-one, what is into function and onto function. The goal is to keep us abreast with the concept of mathematics. If you like this video, don't forget to give a thumbs up, share with your colleagues. If you have any suggestion, any submission you want to give concerning the tutorial, how we can grow together, don't forget to do that in the comment section. See you as we get interactive in the comment section. Bye.